Welcome and thank you for joining us for another training in the Jane Irrigation training series. And I'm Richard Restucia, Vice President of Water Management Solutions for Jane, and I'll be your host again today. And today we're going to be talking about fertilizer management using today's available technology. And this is really a three-part series, and we're going to focus really parts 1 and part 2 on nitrogen, because nitrogen is such an important subject and there's a lot of controversy out there about nitrogen, and we're going to try to clear some of that up and make you all more educated about how to use fertilizer, what fertilizers to use, and how to use them. And so that's a lot to talk about, right? But we've got this whole soil water relationship that plays into part with fertilizer as well. And with such a complex subject, we're really fortunate to have Eric Olson with us today. Eric is the president of Jane Irrigation, and a lot of people don't know this, right? Everybody knows that Eric's been involved his whole life in agriculture, but he did get his undergraduate degree from the University of Minnesota in chemical engineering. And for those of you who know the reputation of University of Minnesota, chemical engineering program there is probably arguably the top program in the nation. So with this combination of background in agriculture, chemical engineering, as well as ag tech through all the ag tech acquisitions Jane and Eric have done over the years, we have the perfect person to really talk about this subject. So with that, I want to say welcome, Eric, and how you doing today?
Great, Richard. Yeah, thanks for the introduction. I'm so happy to be here. I'm excited to talk about this topic. Fertilizer. It has a huge impact, as you'll see, helping growers grow better crops. And, you know, it also has a, tremendous impact on the environment. And, so I'm excited to talk about these technologies, how they'll help us grow better crops with, not making, less of an impact on the environment if we can. The presentation that I put together, nitrogen's pretty complex, so I just want to start with some basic facts. I want to share this nitrogen cycle that we have, talk about the nitrogen usage that's happened over the years since the 1960s, share some crop impacts. I think you'll be really surprised, and then get into the technologies for this, helping growers manage nitrogen. So some interesting facts about nitrogen. I think everyone knows this, that nitrogen gas makes up 78% of the atmosphere, and it's all around us. The second bullet point there, hopefully you've seen this experiment in middle school chemistry or college chemistry, where the teacher takes out this vat or vial of liquid nitrogen, and they pour it on the ground, and it goes poof. And it kind of blows, it disappears, and that's because the boiling point is a minus almost 200 degrees C. So that's interesting. In 1910, this guy by the name of Fritz Haber came up with this process that later became famously known as the Haber-Bosch process. But he was able to take nitrogen out of air, combine it with hydrogen gas, under heat and pressure to make fertilizer, to make ammonia, which really changed agriculture for there on. And that process invented in 1910, and then the chemical engineering of that with the Bosch, inventor really helped, change the, nitrogen and got the commercial nitrogen process going, and really had a big impact on ag from the 1940s on. It's a stable molecule. It's got this triple bond, so it's kind of hard to break, but it can inform a lot of different chemistry. Nature can actually make nitrogen on its own. We have plants that exist that will do this Haber process, that these plants will take nitrogen out of the air and create nitrogen in the soil. And these are soybeans, legumes, alfalfa. And that's why you hear people making crop rotations from corn and soybeans, because the soybeans will put some nitrogen there and the corn might take the nitrogen out. I've heard people say that if this Haber-Bosch process were not invented and you couldn't get this amount of nitrogen out, that we might be only able to feed 6 billion people instead of 8 billion people. And I'll show some graphs on that in a minute. Nitrogen's pretty complex, and in ag and landscape, when we apply nitrogen fertilizer, they can come in many formats, and it's super confusing. If you're a non-chemical engineer, I don't know really how to digest that. And over the next 3 presentations, we hope to make this much easier for people to understand. But you know, if you've been in agriculture or you're using nitrates in fertilizer, these are some of the common fertilizers you'll see. You can see calcium ammonium nitrate, that's known as CAN 17. UAN is ammonia, urea ammonium nitrate. And these are some different popular forms. The most popular probably worldwide is urea, and that gives 46% nitrogen when you apply it. So one other key aspect here is nitrogen moves readily with water through the soil, and nitrogen moves in the plant. And that, you know, can help us, and it makes some real challenging conditions on the environment that we'll talk about. And, you know, why are we talking about this? An irrigation company talking about nitrogen? Well, growers' expense, if you're a corn farmer, up to 20% of your inputs and your expense to grow that corn crop is going to could be on nitrogen. You know, for higher value crops, it's less, but it's a significant part of your budget there. Getting into the nitrogen cycle. Now, again, nitrogen is all around us. The atmosphere makes up that N2 at the very top of the graph there, or picture shows N2. And the N2, there's a lot of things that can happen to this nitrogen. We can take that Haber-Bosch process and convert N2 into ammonia. Ammonia is NH3. And then NH3 then further goes into NH4 through a series of different reactions. So we have this unique environment where nitrogen is changing forms. It's changing forms in the soils, it's changing forms in the air, and it's being helped by either industrial processes like the Haber-Bosch or biological fixation processes like soybeans. And for growing crops, we need to get this nitrogen in the 2 forms that can be used by plants. The main form of nitrogen used by plants is nitrate, and that's NO3. And so if you can't get the nitrogen into NO3 form, or sometimes NH4, that's ammonium, the crop can't utilize the nitrogen, and then so you have challenges that whatever nitrogen you put down does not get utilized. Now, the environment here in these cycles has to be very good, almost near perfect. You need to have the right temperature and humidity and the right soil temps and the right pHs to have these reactions happen. And several of the chemical reactions for the people that are chemists or want to understand a little bit more are at the bottom there. And there's a couple key processes. Fixation is just the plants taking nitrogen out of the air and making it through the plant reaction. Emodification is like mineralizing the nitrogen from organic matter, and that mineralization is what you need to actually use it. You know, you think of a mineral, it's like a little piece that we put on. So those are some of the key positive reactions. Some of the negative reactions that can happen are, you know, what's called a denitrification. Sometimes if you have the conditions where the soil might be too wet, it's too hot, you have excess nitrogen, that nitrogen can be denitrified. And there's a reaction that's pretty harmful to the environment where nitrates will actually go into nitrous oxide, which is 300 times more damaging to the environment for greenhouse gases than carbon dioxide. So we're living in a pretty complex homeostasis, you know, style of environment. You have all these, you know, forms of nitrogen that are happening in some equilibrium. We're either coming or going. We're making nitrates or using nitrates. And the bottom line is we need the nitrates, the NO3, to grow good crops.
Yeah, so Eric, you know, when we first started talking about this, right, and I was talking about nitrogen in my, just in my garden, and you said, well, what kind of nitrogen are you using, right? And all of a sudden I realized that I thought I was fairly educated on this, and I got behind really fast, right, when I didn't know these details. So it's more than just using nitrogen. As you mentioned, the water and the soil make a big difference too. So, you know, how are growers, how are gardeners supposed to learn what's the best nitrogen to use for their crops?
Yeah, that's you know, the good thing for gardeners is the industry's done a phenomenal job of making nitrogen products to put in your garden, you know, on the small scale. And they'll get the right macronutrients, and they might get the phosphorus and potassium along with it. And they'll have slow release coatings where either a water activated, temperature, or a combination of both, so they'll last over time. Without those coatings or slow release, you know, the minute you water that nitrate's gonna, you know, go through the soil, and what doesn't get used by the crop can go deeper into the subsoil, and, you know, hopefully it doesn't, you know, go to the groundwater. That's the thing. But on the landscape, small gardens, you got a great variety of options. They're relatively inexpensive, but if you were to buy those nitrogen, you know, fertilizers and put on an ag scale, it would just be super expensive. It wouldn't make economic sense. So, you know, when you're doing a garden, you can go to, you know, any garden store, and they'll give you some idea. On the ag side, and even if you know, are wanting to grow, you know, you're really into gardening, you could get a soil test. A soil and water test are really needed to get the right nitrogens, you know, deployed.
So thanks, Eric. That's really helpful, you know, and I know I pay like 75 bucks for a soil test, but I also get a consultation with it. I understand what's being prescribed and why, and it's a good 75 bucks to spend, I think, even for a gardener, and certainly for a larger scale operator, it's really important.
Thank you. Yeah, sorry for the delay there. I had a slight technical issue. The next slide shows that nitrogen usage globally, that's really exploded since the 1960s, where we used to use 15 million tons of nutrients and of nitrogen. Now we're using we've increased usage over 50 years by over 100 million tons per year of nitrogen that's being applied. And you can see the growth over the years from the 1960s to the 1990s. There was growth in Europe and Asia, and significant growth in Asia today, where we have, you know, more than 60% of the nitrates in tons per year utilized out of Asia. The biggest growth market for growth of utilizing nitrogen is happening in South America, and you're getting some growth in Africa. There's a pretty good dip or drop in the 1990s in Europe. So that's kind of, you know, the amount of growth, and I'll kind of show you why and how this correlates on the next few slides. Now, in Asia, you could see this, you know, pictorial here shows, you know, the amount of nitrogen by country, and you can see the darker the red, the higher the nitrogen used per hectare of cropland. And you could see India and China in that, you know, 250K to 500K region of usage of nitrogen per hectare. You can see the U.S. maybe around 100, and you can see a variety of countries using quite a bit less, you know, from the former Soviet countries and countries in Africa using quite a bit less there of total nitrogen.
So Eric, Asia, you know, with what, a little bit more than 40% of the world's population is using a lot of nitrogen. Is there anything we can learn from them as a result of seeing what the amounts of nitrogen they're using?
Yeah, that's a good segue into this slide where this is cereal yield versus fertilizer usage in 2017, and you know, these are all the countries here that track this data, and so I drew a trend line there so you could see a general trend of fertilizer usage with yield in that it correlates to some degree, and that's why people say, well, does fertilizer nitrogen use correlate to yield? And a lot of times models will say, well, I can explain 60% of the variation in that correlation trend. But it doesn't explain it all. In two countries that I'm familiar with, United States and India, we can see both countries are using about 100 kilograms per hectare of nitrogen on cereal crops. But one country is yielding 3 times more on about the same amount of nitrogen. And you can see this, you know, these examples. Anything above that line, people are yielding higher, and below the line, people are yielding less for the same amount of nitrogen. So, you know, it's a complex question, Richard, about, you know, why they're using more nitrogen and why people are using less. I think for a long time, people thought that just more nitrogen is better, and we still probably have people thinking that that's the best way to get a yield and make a good crop. And if nitrogen's cheap, they'll put it on and try to get the biggest crop they can. But you get some deleterious effects on the environment. And the plants, really, there's a sweet spot on nitrogen. They're only going to take kind of so much of what they need. Otherwise, there's going to be other challenges with growing that crop. You might get too much green mass growing, or where you actually don't get a productive crop, what you're looking for. You could get toxicity from the chemical as well if you overdo it. If you underdo it, you're going to stunt the growth. So there is a sweet spot in nitrogen. And, you know, who's right here on this graph, India or the United States? Well, probably the answer is might be right in the middle there somewhat. But it's complex, and there's so many variables in farming. And that's why, you know, the next slide I'm really kind of excited to talk about. Being in agriculture my whole life, this is a phenomenal picture. It shows corn yields in the United States from the late 1860s to really today, and it shows an amazing 5-fold increase in yield since the 1930s. And we're still on this trend today, and that's not all because of nitrogen, but it's also due to hybrids, irrigation, other fertilizers, and soil practices. And this is a phenomenal trend and story. I put my own graph lines on there to just kind of show the general trends in the variance. It's not a straight line trend. There's good years, bad years, there's droughts and things that happen, but in general that trend is strong. Now this is the average yield of corn, and you know, for the people in the United States here that you know might be a little challenged as far as creating those metrics. The average yield this last year for corn was 176 bushels an acre, and that's about 11 tons per hectare. So you can, you know, see that this trend is continuing up to 2019. We got 11 tons, 176 bushels an acre. What's happened since 1990 and even 2000? In 1990, we only had 119 bushels an acre yield. So we've gone in 20 years, 119 bushels an acre to almost 180 in that amount of time. And that's really done by a phenomenal job by the U.S. corn growers and the farmers in this country. It's a tremendous job. We also see similar increases in almonds, another crop near and dear to my heart. The average almond yield today is 2,200 pounds an acre. And in the early 2000s, late 1990s, it was over, a little over 1,000. I think in the year 2000, it was 1,400 pounds an acre. So 1,400 pounds an acre to 2,200 pounds an acre in just 20 years. So most crops we're seeing this type of yield increases due to the tremendous job by our farmers and the ag complex. There is, though, this variation, and I put those green lines there that these yields I've talked about, these yield gains, not everyone's getting those yield gains, and that's an average number. So in corn, for example, the average yield might be 180 bushels an acre. We got farmers getting near 400 bushels an acre, and we have others getting 100 bushels an acre, and that's really due to the genetics of the corn, the irrigation and the fertilizer application, the utilizing of technologies with precision ag. And we have the same thing on almonds. If the average almond yield is 2,200 pounds an acre, there's farmers that are getting 3,500 to 4,000 pounds an acre, and then there's orchards that are yielding 1,200 pounds an acre. And I'm really passionate about helping our growers figure out how to reduce the variation in their fields, because there's not only variation from farm to farm, but there's variation within the field that you wouldn't believe. On our family farm with my father-in-law, he's a corn farmer, and I remember sitting in the combine so many years watching the yield monitor go from 220 to 240 bushels an acre. So as a statistician, I like seeing, well, what's the standard deviation of that? The standard deviation on that, might be, 20 or 25. So you're getting quite a big, field variation, and that happens in most crops. So, the good news is I think this yield trend can continue on most crops. It's our job now to reduce the variance and put our energies to figuring out the variables that will help everyone improve the yield and do a better job with less fertilizer, because there is a significant environmental impact that we have in agriculture, and people have seen the statistics about the amount of fresh water that we use in agriculture. It's we use most of the water around the world, freshwater withdrawals in ag. And the item from this table, the chart here that I'd like to kind of highlight that probably most people aren't familiar with, it's that second from the right bar called eutrophication. And eutrophication is basically the greening of our streams and waterways and lakes and oceans. And you can see here from this study that eutrophication is 78% of the global eutrophication is due to agriculture. And that what happens is the nitrates can go to the groundwater, or phosphorus runoff can happen, and nitrogen and phosphorus then make the waterways green with this blooming. And there's a picture of this algae bloom, and the problem with this is when you get those nutrients and the explosion of this plant growth, the waters get less oxygen, and then they can't support the fish. So if we put too much nitrogen on that goes into the groundwater, into the streams, or too much phosphorus that we get runoff, that's the picture we get. And we're having these problems worldwide. And so it's very important that us as ag and irrigation professionals, we get the right fertilizer at the right time so we don't get these runoffs or a deleterious effect. Another main issue facing agriculture is greenhouse gases, and I talked earlier about this denitrification process that if you have over waterlogged soils and too high of temperatures, and you have ammonia in this waterlogged soil, with the right microbes, you will create a chemical reaction that releases nitrous oxide into the environment, and nitrous oxide is 300 times as potent as CO2. And so while you can see on the chart there, it's a small amount that's coming out, but nitrous oxide is really potent greenhouse gas. So we need to, again, get the irrigation right and don't overwater, and get the fertilizer application right, and then you won't create nitrous oxide. Another big issue in the Central Valley of California is managing our drinking water. The drinking water standards that the government limits has a limit of 45 parts per million on nitrates in drinking water, and above that, there's serious health consequences and issues. And we have many wells in the Central Valley that are at or near that level. So if we can put nitrogen on at the right amount, the right time, and we don't over-irrigate, so we flush those nitrates into the groundwater, we can, over time improve the groundwater quality in the drinking water. If you have nitrates in groundwater, then it's very expensive to remove those, and some communities just don't have the infrastructure to get those nitrates out.
So Eric, is there a good way for somebody to see if, well, I can see your next slide is going to answer this, if they are putting too much nitrogen on, if it's leaching into the groundwater, how would a grower know this?
Yeah, so that's that was the warm-up, the background a little bit on nitrogen, and now we're excited to present some technologies that can really help that yield trend and help our growers do a tremendous job in feeding the world while doing a good job with the environment. And we have some amazing tools and technologies that are in use today, and I just wanted to share those. The first bullet point here, I'm not going to talk about today. I'm not a fertilizer expert, and that should be left for them. But they've created this really amazing time-released nitrogen or environmental release nitrogen, and that is really helpful, that the nitrogen will get holed up in the soil and it doesn't get flushed into the groundwater so easily. And so that's a tremendous invention. Obviously, it has some more costs, but that I think is worth it because it helps the environment, and you still get a good crop, and you get much better nitrogen use efficiency by using that time release if you can manage that. The other technologies I'm going to mention below here, I'm going to specifically talk about, and I've talked about it in some previous presentations, and I'm really excited. Soil moisture, and then soil moisture sensing and remote sensing. But the first really tool to help us manage nitrogen, and this is large-scale ag, I would say. Large farmers could maybe invest in this technology, or your fertilizer company or ag retailer. I'd highly encourage them to buy one of these devices. This is made by the 360 Yield Center, and it's called 360 Soil Scan. And what it is, it's a portable soil testing system that will, in the field, in little as 5 minutes, give you the nitrate measurement in terms of parts per million in your soil, and it gives you soil pH as well. So, so picture this, 2 foot by 2 foot box here that you can put in the back of your truck. You drive out, do some different soil testing. In an hour, you got a good idea of what's happening with nitrates in your field. So you're not putting nitrates where, you're not putting too much nitrogen on. You can, adjust your nitrogen based on this, and it's really a phenomenal tool. Richard, I know you're probably going to ask, well, what does that cost, right? You have to go to three. Well, I want one too. There are several thousands of dollars but you contact 360 Yield Center and you can look at that. But that's a really awesome technology where you don't have to go dig up soil, put it in a bag, take it to a soil lab, wait a week, and then get your results back. This is really on the fly. So again, I wanted to let people know that. The next area I'd like to talk about is utilizing soil moisture sensors and software to help you manage water and infiltration rate, and also to help you manage fertilizer and how fast that goes through the soil. So today, these are tools that we have in our agronomic data platform called Jane Logic. And that Jane Logic, these pictures that you see here are in the middle left of the screen. Those are the soil moisture at different depths, going every 12 inches down to 5 feet. That's the trend. And you see those little zigzags. Those zigzags are when we have an irrigation event, the soil moisture increases, followed by the downward trend is the plant using the material or water, going out through the bottom of the root zone. And so that's what a traditional soil moisture chart would look like. That's pretty complicated. You have to really know and study and use these to be effective at managing your water, to see if the water did go past the root zone or not. And we've created a tool that's much easier for our growers and irrigators to, in one picture, see how deep that water goes. And that's called the infiltration rate graphic. And it takes basically that chart on the left and makes that picture in an easily digestible format, the chart on the right. And you can see, if you look close there, you can see we have a desired irrigation zone, and that's the root zone, going from 0 to 60 inches. And the desired irrigation or root zone in this example goes from 24 to 48 inches. And that triangular blue shape is the water movement through the soil profile, taking the data from the chart on the left and making one graphic. And those vertical blue lines there, those are the irrigation events. So you can see those first 3 bars in the middle there. Those are actually irrigation events where we didn't see much infiltration. That larger bar next to it shows you how deep that irrigation went. So why is this important? Well, nitrogen gets dissolved in water and acts like a salt. It breaks up into positive and negative charges, and those negatively charged nitrates will move with groundwater. It'll just move with water right through the soil. So if you push water past the root zone, you're going to carry nitrates with it, and you're going to go right past the root zone, and you're going to have waste of your nitrates. So the bottom picture there shows what a really very good irrigation picture looks like for different, and this is probably an almond crop, and you can see the desired root zone again, 24 to 48 inches. We obviously don't want to send water past 48 inches because you're going to carry water, you're going to waste water, and you're going to waste fertilizer. You can see a couple of those irrigation events got the water right in the middle of that zone, and a couple of them didn't make that. So this Jane logic with soil moisture sensing with our software that our team has developed has made this very easy to get the timing of irrigations so that you get water and fertilizer right in the middle of that root zone, that you don't push water and fertilizer past the root zone, and you want to make sure you get it there to the root zone. So that's technology that we're in use today, and we have many Jane Logic customers doing a phenomenal job managing water and nutrients in this manner.
I love this, Eric. It takes away the guessing game, right? It'd be like driving my truck without knowing how much fuel was in the tank unless I had this vision of what's happening below the ground level.
Yeah, it gets better yet, Richard, in terms of nitrogen management. Now this next slide, so if hopefully everyone could kind of follow that explanation. This next slide, it gets a little more busy, but if you can bear with me, we're looking at soil moisture here along with EC, which is called electroconductivity, and it's called salinity sensors on here, but it's really an EC measurement, electrical conductivity. And so the bottom half, those bottom 4 lines there, those are EC measurements or salinity, and the top 4 measurements are soil moisture. And I want you to look at the left half of the picture versus the right half of the picture. The left half of the picture is a growing area when we over-irrigated. We irrigated beyond field capacity. We got too wet, we got saturated. And you can see that by that very top squiggly line, that squiggly line is a soil moisture content running into the blue, means that we over-irrigated that. And if you follow that line all the way through, where we have soil moisture content in the range, that's running like between the lines there. We're running in a very good range for soil moisture. So the left-hand part of this irrigation events are over-irrigated, probably beyond field capacity. And the right-hand side here is soil moisture in the proper range, where we're managing it between field capacity and some management irrigation zone. You don't obviously want to go to the wilting point, but you're in some management zone. And so if everyone can, follow that, the left hand, again, Richard, can you see my cursor moving around there?
I do not for some reason. Yeah, sorry, but
that's it. Well, you can, the three left arrows then, when you're looking at that salinity or those EC measurements, we can see that during the nitrogen, when nitrogen is put into the water, we can see that nitrogen actually goes down all the way to 16 inches. We can see that response curve from those arrows in that increase in salinity. Now, that's what happens when you have an over-irrigated or beyond field capacity and you put fertilizer down. That fertilizer is going to go straight through. So in a very short amount of time, that fertilizer went all the way through to 16 inches, and this is a vegetable crop. Now, if you look at the graphs over on the right-hand side, you can see we irrigated, and again, we're irrigating within a proper management zone between field capacity and a management zone. And you can see that the salinity increases at the 4-inch level. There's a nice hump there, and that nice hump shows the fertilizer. We can see that fertilizer got to 4 inches. And if you look really close, you can see at 8 inches there's a minor hump. So most of that fertilizer went to 4 inches, but didn't go past 8. Whereas in the over-irrigated scenario, that fertilizer went all the way to 16 inches, and we can see it because this nitrogen is like a salt. It breaks apart, and we can use EC to help make this. This is available in Jane Logic for all of our customers that have EC soil moisture sensors, and many profile sensors are available. We buy and support Centec among a few others, and you can see that in the drill and drop. So this can be a plug-in, and we have some growers that are really managing this nitrogen and the application and timing of nitrogen very well with the utilization of EC sensors.
Yeah, this is so great to see it in that graphical form because, right, if I'm understanding this correctly, if you water too much while you're fertilizing or if you're fertigating, it's like not fertilizing at all if you just push it past the roots.
Yeah, correct. And you think about the the environmental impacts too that you have. You have the waste of the fertilizer. What if you were wasting 20 or 30% of your fertilizer? That's a significant cost, right? So it's not only the environmental impact that you have, but you have the cost side as well.
So Eric, we do have a question. We do have a question for one of our viewers, and they're asking, do you have a soil moisture sensor that you particularly like? There's many that are good. We partner with several soil moisture companies. The drill and drop soil moisture sensor by Centec is a good one. It's got great EC capability. But there's many that we use and sell and support as part of Jane Logic. Jane Logic is a hardware agnostic. And so we can plug in pretty much any soil moisture. But we do like the profile one because you want to see the water and the fertilizer move through the profile versus there's some EC sensors that are kind of the singular probe, and they only give you the EC at one point. It's important to be able to see this profile, this change of water and fertilizer going through the soil. So that's critical, a profile versus a single point sensor, okay? So it's number one, not all of the soil moisture sensors have EC. So you have to be sure you get one with EC, and one, you want multiple points of EC if you want the best.
Correct. Well done, yep. Okay, so I'm passionate also about remote sensing, and we've been talking a lot about remote sensing and adding amazing technologies into JaneLogix, supported by our partner AgroLogix, and we're getting the ETC now into JaneLogix. That's rolling out as we speak. But to help us manage nitrogen, there's a pretty good researched index called the Canopy Chlorophyll Content Index, the CCCL index. And it's, if you know and heard of NDVI, the Normalized Difference Vegetative Index, that's very popular for looking at vigor of the crop, and many people know that and see that, and that's been well studied. There's a minor adjustment to this index where we're looking at the red edge of this electromagnetic spectrum, and it's a minor calculation difference to give this red edge, put this into this calculation, and it tells us, gives us an idea of how much nitrogen is actually in that crop and in that canopy. And then when you have that and you have the map and the uniformity of that, it can help you give you precise nitrogen application. It can help you with timing. And there's several people that have this. We're working on bringing this into JaneLogix as well. So not only will we be able to help with irrigation from the satellite with ETC, but we want to bring and be able to support the growers and customers of JaneLogix with fertilizer recommendations and support. And so that's this CCCL index. And from looking at this satellite image, you could see that the dark green is obviously the crop has nitrogen for to be able to be used. If you have a yellow-green spots in variation, that crop has a variation with where the plants might not have available nitrogen, and you got a red area. They're not really having any nitrogen available for the plant. So pretty awesome technology again from remote sensing. This could be satellite and/or drones, fixed-wing flyovers. There's going to be many applications to get this data and these recommendations.
I love that it's so intuitive with the colors, right? I want my field to be green, and you can see it right there.
Yeah, and you want it uniform, right, is the key thing. So hopefully you got a new appreciation for nitrogen and just how complex it is. And I am so lucky to have this chemical engineering degree because it's a lot easier for me to understand based on my past studies. But it's complex. It's hard to manage. It's hard to know when to put on the nitrogen and what form to put it on. And if you put on the wrong nitrogen, for example, you could be making your soils worse. There's certain nitrogens that'll make your soil more acidic, and some will make it more basic. And if you don't, get the right amount on or the right, product, you're gonna, make your soils worse. So I would say get help for sure, and get help from your local crop CCA or PCA. Universities and extensions have wonderful information about nitrogen and what nitrogens and how to put it on, and really a phenomenal job by our universities there. So in your area or whatever crops are growing, there's specialty universities that can help you. Your fertilizer suppliers can help you too on that. Also irrigation dealers. Us at Jane Irrigation, we have several certified crop advisors. We can help and support you, and we're really there for the growers and end users. I would say it's a lot like water, Richard. We have available technology to make a huge difference in nitrogen management. Let's utilize it, right? Let's utilize this EC. Let's utilize these soil moisture sensors. Let's utilize the remote sensing to help us manage this so we're not putting excess on. And I didn't talk about this, but there's these 4 R's of nitrogen management, and these are absolutely critical. You want the right source of nitrogen. Again, if you get the wrong type, you might make deleterious impacts to your soil. You want to put it at the right rate. If you put too much on too early, you're going to be wasting it and maybe having an impact on the environment, you want to put it at the right time for the crop when the crop needs it, and that's critical. And then, you know, you want to put it at the right place. Do you want to spread it out, broadcast it across the whole field, or do you want to get it right to the roots of the crop? And one's going to be better for that. And I think the final point I'd like to make in summary, hopefully from those soil moisture pictures in using that infiltration chart and the EC graphs, that you could see and understand that you don't have a very good and efficient irrigation system, it's almost impossible to have good nitrogen use efficiency, and it'd be very difficult to not have a bad impact on the environment. So, you know, let's make sure we're designing and putting in good irrigation systems with good distribution uniformities, because I think it all starts there. If you get a bad distribution uniformity irrigation system and you put that fertilizer down, you're going to have that yield variation that I talked about earlier, that low corn yield or the high, you know, the low almond yield. And for us to improve, it starts with getting an amazing irrigation system with good uniformity out there. And from there, then we can talk about precision irrigation, precision application. But these are easy things that we can do today to help our farmers yield better and, you know, do it in a manner that's not deleterious on the environment. So thank you, Richard.
Yeah, so one thing's for sure is I of course get very interested and excited about the sustainability side of this and the importance of not using too much nitrogen. The other thing that really gets my attention, Eric, is that you're talking about the yield variations, and we were talking early on before your presentation about how the yields are really good in the Central Valley of almonds this year, which affects the prices in a negative way. So, man, on a good year for production, but a bad year for pricing, I definitely want to be in that high end of variability. I don't want to be having a bad crop year when the prices are down. And this is really manageable, and having the right tools to make sure that you're having a good production year when the prices are down so that you have decent profits for the year is so important. That really hit home for me today. And of course, all the talk about fertilizer and nitrogen and what an important variable it is in the success of a grower. When we first started talking about this, I said, wow, we're really just scratching the surface and we need to have multiple parts. So and that's when you agreed to do the 3-part series. And we're going to be back with part 2 next month. And that's going to focus on application rates and selecting the right nitrogen for what you're doing. And then finally, we'll be finishing up in October with phosphorus, potassium, and the other micronutrients. So, Eric, I want to say thank you to you for a great presentation. You make a very complex subject, not only easy to understand, but also interesting. And that's a real talent. So thank you for doing that. Thanks, everybody, for taking time out of your day. You know, I know everybody's really busy these days. And to take that time to hear what we have to say is really important to us, and we appreciate that, and we hope we're giving you the content that you want. And then finally, don't forget, you can now listen to us on all your favorite podcast sources, including Apple, Spotify, and Google. So, you know, tune in there to some of our other trainings, and you can always see those on the web, but sometimes it's just easier to do it on the podcast. So again, thanks very much, Eric. I really appreciate it, and we will see you for part 2 in about a month.
Thank you, Richard. Take care.
All right, thank you.